Okay, so the problem reads, if I could read the problem, it reads, where's the problem? Use bond enthalpies to calculate the heat of combustion of methane, the principal component of natural gas. I'm not sure there are a lot of components of natural gas. Natural gas is pretty clean. There may be some ethane in there, but it's pretty clean stuff, as opposed to LPG, which has all kinds of stuff in it. LPG is not liquid propane gas, it's liquid petroleum gas, so it has a lot of things in it, as opposed to the propane that you cook your gas with. Just a side note that petroleum byproducts are oftentimes mixtures, solutions, like gasoline is mainly octane, but it has a lot of heptane in, 7 carbons, octane, decane, nonane. Okay, so it's not just one thing, they're mixtures. Kerosene is a mixture. You call it fractions. A fraction of the long carbon atom, the oil, it comes off as fractions. When oil is released, crude oil, oftentimes the volatile layer will evaporate into the atmosphere and you're left with a thick tar. When the higher volatility components, the ethane, the propane, the butane, when they evaporate, you're left with the tar, the thicker component of the natural gas. But when the crude oil comes out, it's a mixture of all kinds of things. All right, so what we've got to do is we've got to draw this by looking at the bonds. Now, you're going to take things from your chapter on bond geometric structures, correct? So this is methane, as you remember, methane, right? Let's balance this first, shall we? We need a 2 here, and that's going to give us 4, and then a 2 here. So that's pretty straightforward, isn't it? Yes? All right, so we have this, plus we have 2 of these, right? And then we have just 1 of these. You remember that? And then we have 2 of these. Right? That's 109.5. 109.5. Shall I make that a little clearer? Okay. We have oxygen. We have hydrogen. Then we have 109.5 degrees. So we have 2 bonds there. So we have 4 of these bonds. So we have 4 CH bonds. What's the bond enthalpy for a CH bond, single bond? Anybody can feed that to me? Anybody? 413. 413?
14.
What is it?
414.
414. Okay, now, when you say it's 414, there are the enthalpies there with the bond lengths, okay? So it's going to be positive or negative, or what's the story with the sign? What is it? Yeah, these are, when you form the bond, don't forget, when you form the bond, you're going to be doing what? You're going to be doing what?
Exerting
It's going to be endothermic when what did I say? I forgot, I repeated myself so many times I forgot what I was thinking. When you form the bond, you're going to be releasing energy, correct? When you break the bond, you have to put the energy into it, right? Okay, so what is this? This is plus 414, is that correct for each one? Is that correct? Okay, so we have 4 of them, right? All right, now what about oxygen double bonds? So we have 2 oxygen double bonds, okay?
498.
498 each?
Yeah.
Okay. 498 each. Okay, good. Okay. And what about this? You have 2 carbon oxygen bonds.
804 each.
804 each, wow. 804 each. Right? And you know that that's very stable, don't you? Because the carbon dioxide molecule is nonpolar, it's linear, very stable. And what about the hydrogen-oxygen bond? We have 2 of those.
463.
No, we have 4 of those, right? Sorry.
463 each.
463 each? Sorry. Hydrogen, oxygen bond, and what did you say, 463?
Yeah.
All right, now let's make sure we got this right. So we have 4 of these, is that correct? Okay. We have 2 of these, is that correct? Okay. We have 2 of these, so is that correct? Okay. So now we're going to multiply, now we're going to multiply out. Okay. What is, now remember, these are going to be forming, right? Yes? They're going to form, right? Okay, good. So what do we got? What do we got? What's this? Come on, guys, you can do this with me. Come on. I know that. I don't think anybody knows. It's like 8:30 in the morning, and it's the middle of the week. It's a tough day. Okay, what do we got?
1656.
1656. Okay. All right, and what's this one going to be? That's like 500, so that's 1,000 minus 4. 996. Yes? What else? Now, is this going to be negative or positive?
Negative.
Yeah, that's going to be negative. Why is it going to be negative?
Because bonds are forming.
We're forming, yeah, exactly. So what's this going to be?
1608.
Well done, Lauren.
Thank you.
Mental math is good for you, even when you get it wrong. It's still good. You should always practice mental math. Do you know that you will make brain cells? You know, you're born with the number of brain cells you have, and you kill them, right? That's untrue. You can make more brain cells. And doing mental math is a great way to generate brain cells. So if you want to, get even smarter, do mental math. And the worst thing that's going to happen?
Is you're going to be wrong?
You're going to be wrong. It's not like you're going to, hear a knock on the door at 2 a.m. in the morning. This is the mental math police! You're under arrest! You don't do prison time because you get a mental math problem wrong, okay?
A division of the significant figure, please?
It's actually not a division. It's actually in the same office. They're just different door. Significant figure police is right next door to the mental math police, but same office, same division. Same division, same office, okay? Now, so what do we got here? We got this, this is plus and minus, and what about this? What's this going to be? 9 something, right? Negative, good. We got to start, excellent. Got to start. 900, look, girl, you're doing it, right? So 900, and then 13 times 2 is 26, so 926, right? Right? You get it? In other words, 450 times 2 is 900. You got 13 left over. Am I wrong?
It's times 4.
But it's times 4, so you can double that. 1852. 1852, excellent year. 2 years after the Missouri Compromise, was that 1852? There was a compromise in 1850 something in the United States, sorry.
I think that was when we let Missouri in to the Union, and they were allowed to keep their slaves because we wanted to keep the Union in.
Well done. I'm not sure that's correct, but it certainly sounds good. I think you might be right. Excellent. Something with, right.
Yeah.
Who was president? Let's see. That was an election year, right? 1852. I don't think anybody at home really cares. Probably Millard Fillmore was elected in, I don't remember, Polk, and then maybe, I don't know.
It was one of the unimportant presidents.
It was one of the very important presidents, but he didn't do much.
Yeah.
Those presidents between Polk and Lincoln were pretty awful.
Yeah.
Okay, so So then, what do? What's this sum here? What's that sum? And am I still on the camera?
Yeah, well, you are kind of out of frame.
I'm out of frame, but this is all in frame?
Yeah, that's all
Okay,
good.
so what's this sum here? 1608, excellent. 1852, 2 good years. So what would that be? Mr. Munkle, do you want to join us or something, or what do you think, big guy?
Negative.
Can you add that?
Yeah, negative 3,460.
And you were just going to sit on that answer, right? Negative what?
3,460.
Negative 3,460. Well done. Excellent. And then, is this correct? 4 times that, 2 times that. So what do we got? Is that right?
Is that meant to be the same as that but positive?
Excuse me?
Is the one on the left meant to be the same as the right but positive? So
No.
that balances out?
No.
Okay.
No, because it's different bonds, different compounds. So what's this going to be? 1656 plus 996.
26, 52.
What is it? What do you got?
26, 52.
What is it?
26, 2, 6, 5.
2652. And that's going to be endothermic, right? Now, let me make sure we're on frame so that we are just about on frame, but not bad. Not too bad. Not too bad. Okay, made a little bit of a mistake. I'm having a little bit of a problem with the way the book is explaining it, but the idea isn't this minus this, where you're coming up with some formula. You want to know what is the difference, what you do the difference, and you do it by inspection, really. So this is going to be negative. This is going to be negative 460, and that's going to be positive 2652. So the difference is going to be, if you combine them, you add them together, you find the difference of the two, you're going to come up with what? What's the difference?
808.
808 what?
The book says kilojoules per mole.
Kilojoules per mole. And that's what it is, because you're doing per mole of this, per mole of methane, right? But this is what's key. Is it going to be negative or positive?
Negative.
It's going to be negative. It's going to be negative. Okay? So, the book is coming up with a formula, but you have to do it by inspection. You say, well, what's the difference? It's 808, but is it a endothermic difference, or is it a exothermic difference? Do it by inspection. Clear? Are we good? Yes? Yes, Lauren.
This chapter seems very simple. What is the catch?
The chapter seems very simple. What is the catch? There is no catch. I think I explained this to you before. And it's just that it's very binary in a sense. There's only positive and negative, exothermic and endothermic. It's very binary. The answers are either positive or negative. It's zeros and ones. There's not a lot of opportunities to go off on in different directions. Thermodynamics is a very, very straightforward. It can be very difficult, but a friend of mine took statistical thermodynamics in graduate school and said it was hard. But the idea of thermodynamics relative to some of the other things you've learned is very concrete, very sequential, very predictable, very binary, positives and negatives. Easy?
And it's easier to say than stoichiometry.
It's what?
It's easier to say than stoichiometry.
It's easier to say than stoichiometry, and you sound infinitely more intelligent when you can say thermodynamics as opposed to stoichiometry. When you say stoichiometry, people might think that you're having some kind of seizure disorder or some kind of weird Tourette syndrome. So stoichiometry, it just sounds weird. You don't sound intelligent, you sound a little goofy. But thermodynamics makes you sound very intelligent. Okay, so try to use the word thermodynamics at least 3 times a day to feel better about yourself, okay? Excellent. Let me just pull this around so you can make sure it's all on the screen. Okay, you can inspect that, and we're off.